A current of 10 ampere flows around a closed path in a circuit which is in the horizontal plane as shown in the figure. The circuit consists of 8 alternating arcs of radius 0.08 meter and 0.12 meter. Each arc subtends the same angle at the center. Find the magnetic field produced by this circuit at the center. The next one is an infinitely long straight wire carrying a current of 10 ampere is passing through the center of the above circuit vertically with the direction of the current being into the plane of the circuit. What is the force acting on the wire at the center due to the current in the circuit? What is the force acting on the arc AC and the straight segment CD due to the current at the center? So this one is a very interesting problem. So in order to begin with it, we first of all determine the value of magnetic field, which is also the part 1. So we are beginning with the working formula, which I have already mentioned, that V is equal to mu naught Ni upon 4 pi r into alpha, that is the angle which the arc is subtending. So in this case, the question is saying that they are subtending the equal arcs. So if we consider that they are subtending the equal arc, so I can simply say that the larger circle is going to combine together to produce a semicircle, and the smaller ones are also going to combine together to produce semicircle. That is, each one is contributing to an angle of pi to constitute the entire loop. And hence I can say for the larger and the smaller loop, we are considering the radius being r1 and r2 respectively, where the question is calling us that r1 is equal to 0.08 meter and r2 is equal to 0.12 meter. So if the bigger loop is combining together to contribute for pi angle, so I can say that due to the bigger loop, we are writing V2, which is equal to mu naught I upon 4 pi. The radius is equal to 0.12 and the angle which it is subtending is pi. So it will cancel out. And similarly, for the smaller one, we write mu naught I upon 4 pi. The radius this time is 0.08 and it is also combining together to subtending an angle of pi, which we cancel out to obtain something like this. And since all of them are producing the magnetic field in such a way that the direction of magnetic field is directed outside the plane of the screen, that is directed outwards, so I can say that the two values must be added together to give us the net value of magnetic field. And hence we say that B net is going to be the sum of B1 plus B2, and it will be directed outside the plane of the screen. So we obtain from here by adding the two expressions which we obtained in the previous page, that is this one and this one. If we substitute the value of mu naught and the value of current, that is equal to 10 ampere, so I is equal to 10 ampere, we solve and obtain a value equal to 6.54 into 10 to the power minus 5 Tesla. So this is the value of magnetic field that we obtain, 6.54 into 10 to the power minus 5 Tesla, which is directed outwards. The next, if we read at the problem, it is stating that an infinitely long straight wire carrying a current of 10 ampere is passing through the center of the above circuit vertically with the direction of the current being into the plane of the circuit. What is the force acting on the wire at the center due to the current in the circuit? What is the force acting on the arc AC and the straight segment CD due to the current at the center? So if we consider this part, so the first part, the value is going to be 0. The force acting on the wire at the center is going to be 0 because it is carrying current. The current is basically directed into the plane of the circuit, and the value of magnetic field is coming out of the plane of the circuit or out of the plane of the screen. So I can say that for the B part, the first portion, that is the force acting on the wire at the center, is going to be 0, because the angle between the external magnetic field produced due to the arcs and the current carrying wire is making an angle of 180 degree. So the value of ILB sine theta, that is the magnitude of force, will come out to be 0. The next one, we are calculating the force on the arc AC due to the current at the center. Now, due to the current carrying wire which is infinitely large, we say that magnetic field due to infinitely large wire is given as mu naught I upon 2 pi r. So since it is calculating at AC, we are calling this distance as r1, which is equal to 0.08 meter. So this is the value of magnetic field. Now if we look at the diagram back again, on AC, we say that the direction of the magnetic field on any small segment is going to be tangential. So if the current carrying wire is directed into the plane of the screen, that is the current carrying wire is carrying current like this, then the magnetic field which it is going to produce is going to be in a tangential way at any point at a distance r1 is going to be something like this, with the direction of magnetic field B vector like this along any point which is in the radial direction, and hence the value of force on AC is also going to be 0. So force on AC is also going to be 0, because the direction of the magnetic field on any small segment will be tangential. Now in the next part, we are calculating the force on segment CD. So in the next part, we are calculating the force on the segment CD due to the current at the center. So let us calculate the force on segment CD. So if we look at the location of CD, then it is something like this. Now the CD is directed perpendicular to the value of magnetic field, but the problem is the magnetic field is variable along the length of CD, as the distance from center is continuously changing and it is varying from the closest distance being 0.08 to the farthest distance, which is equal to 0.12 meter. So in order to solve for this, at a distance x somewhere between CD, we are selecting a small patch of thickness dx. So I can show you somewhere here in this way, that we are selecting at a distance x a small patch dx on CD, where we will be calculating the value of force. So I am redrawing this diagram over here, that if this is the length segment CD and this is the center, so we are selecting at a distance x a patch dx, where we will be calculating the force. So this small force can be designated as df, which is equal to I dx into b, where dx is the length of the small segment. So the current is 10 ampere dx into the value of magnetic field, since it is infinitely large wire. So we get mu naught I upon 2 pi x. So for this expression, we obtain as 5 mu naught I upon pi into dx by x. So we are integrating from r1 to r2, that is 0.08 to 0.12. So we obtain this expression on integration, which is equal to 5 mu naught I. So value of I is equal to 10. So I write it as 5 mu naught into 10 upon pi. The value will be ln x, and then we will be putting r2 and r1. So we will obtain ln of 0.12 upon 0.08. Integration of 1 by x with respect to dx will be ln x, where the value of r2 and r1 is 0.12 and 0.08 respectively. and on solving this we obtain 8.1 into 10 to the power minus 6 Newton. Now the next thing we are doing is we are finding out the direction of this force. So this is the magnitude of force which we have obtained. So if we calculate the direction of force, so over here I can say, if we go back to the previous diagram, we are seeing that the current in the wire CD will be in the upward direction. So the current in the wire CD is in the upward direction. So this is the direction of current which we have. And the direction of magnetic field, from the previous problem we have seen that the direction of magnetic field along any distance is going to be somewhat like this. So at this portion the direction of magnetic field was like this, B vector. So we say that B vector is somewhat like this. So if we use Fleming's left hand rule, so I can say that the force is directed downwards, that the force is directed downwards, or basically we can say that it is coming from this diagram into the plane of the screen, where we will be placing our fingers in such a way that our index finger is pointing in the direction of magnetic field, the middle finger is pointing in the direction of current carrying wire CD, and my thumb will be pointing into the plane of the screen. So we say that this is the value of magnitude of force which is acting on CD.